The first unit is called energy around you. So we're going to be looking at all the different forms of energy that we encounter in everyday life. The learning intentions for this unit are for you to develop an understanding of the concept of energy and the various forms of energy that we encounter in everyday life. The success criteria for this unit, so how will you know that you've learnt what we want you to, if you can define these important concepts of energy and work, if you can list and define, explain the various forms of energy that we're going to talk about in this video, so they're all listed here, and if you know that energy is measured in the unit of joules, and if you can convert between joules, kilojoules, and megajoules. So after watching this video, in your exercise book, you should have some notes in your book which include definitions of energy, work, and joules, a conversion chart to help you for converting between joules and kilojoules, and a list of all the different forms of energy that we talk about with a short explanation and a real-life example of each form of energy. So you might want to pause the video now and see how many of these, from these pictures, how many forms of energy can you recognize already? There's 9 different forms of energy that we're going to talk about in this video. So maybe pause the video briefly and see how many you think you can name. So energy is a really important idea and quite a complex idea. But there's a pretty simple definition that we can use, and that's that energy makes things happen. A slightly more technical definition is that energy is the capacity of a physical system to do work. And by work, we might mean to move something, to heat something up, to change the shape of an object. So again, a slightly more technical definition of work. Work is done when a force is applied to an object, and that force moves or changes the object. So if you think back to year 7 science, when we talked about forces, which are a push or a pull, which can change the motion of an object. So this man is applying a force to the box, and he's moving it up the slope. So he's doing work because he's moved the object, and he needs energy to be able to do that work. So energy is required for work to occur. Energy is measured in the unit that we call joules. So you've probably seen energy measurements on nutrition panels like this, so on foods, telling you how much chemical energy is contained within that food. You don't need to write this down, but the definition of a joule is the amount of work done on a 1 kilogram object by a 1 Newton force. So remember, force is measured in newtons. So if a 1 Newton force is applied to a 1 kilogram object and moved 1 meter, then that is 1 joule of energy. And work is also measured in joules, so that's 1 joule of work. Now that's only a very small amount of energy, 1 joule. So we more commonly talk about kilojoules. So 1,000 joules equals 1 kilojoule, just like 1,000 grams equals 1 kilogram. We abbreviate joules as J, and kilojoules we can write as kJ. When we're talking about really large amounts of energy, we can use megajoules as well. So 1,000 kilojoules equals 1 megajoule. Another unit that you've probably heard of is the calorie. That's another unit that we can use for measuring energy. That's sort of a slightly older method, but it's still used, particularly with foods, with chemical energy. So you can see on this panel, the energy is listed in kilojoules and in calories as well. So doing energy calculations, if we want to convert between those units, we can use a conversion chart. So you've used things like this in maths before when we're converting between, say, meters and kilometers. So it's the same process. Because 1 kilojoule contains 1,000 joules, we would need to multiply by 1000. And then to go from joules to kilojoule, we've got to do the opposite. We've got to divide by 1000. So if we wanted to calculate how many joules of energy are contained in 2 kilojoules, so 2 kilojoules times 1000 will be 2000 joules of energy. If we want to calculate how many megajoules of energy are contained in 4,800,000 joules, so again, if we've got joules, we would need to divide by 1000 to go to kilojoules, and then divide by 1000 again to go to megajoules, or we can just divide by 1 million to work out how many megajoules there are. So 4,800,000 divided by 1 million is 4.8 megajoules. Okay, so now we're just going to quickly go through all the different forms of energy that we might encounter. Now, kinetic energy is the energy of movement. So moving objects have what we call kinetic energy. Now, the amount of kinetic energy that an object has can depend on both the speed that the object is moving. So a ball delivered by a fast bowler will have more kinetic energy than a ball delivered by a spin bowler because it's moving faster. And it also depends on the mass of the object. So imagine that this bus and this bike are traveling at the same speed. The bus would have more kinetic energy because it's got much greater mass than the person on the bike. So kinetic energy can be easy to recognize with large objects, but the kinetic energy of small objects is important as well. So if we look at heat energy, or thermal energy is another name for heat energy, heat is generated in lots of situations, from electrical or mechanical devices, in chemical reactions, flames, fire, from the sun, from stars. Living things generate heat as well. But heat is a form of kinetic energy. If you think back to the particle model, again in year 7 when we were looking at chemistry, when we add heat energy to a substance to get it to change from a solid to a liquid to a gas, we learnt that as energy is added, the particles start to move more. The particles start to vibrate, move around. So heat energy is a form of kinetic energy. It's the energy of the vibrating particles. Sound energy is another form of kinetic energy because sound travels through air. The sound wave is propagated through the air. It moves through the air by vibrating the air particles. So sound energy is energy carried by vibrating air. And that's why sound can't travel through a vacuum. Those particles are needed to carry the sound wave. Another form of energy is light energy. Light energy can come from stars, from the sun, can come from light globes, from chemical reactions, so fire, flame, and very hot objects. We'll learn more about light in year 9. But again, light energy is a form of kinetic energy. It's carried by very tiny, fast-moving particles that we call photons. A final form of kinetic energy is electrical energy. So that's energy that's carried by electric charges. You might know that electricity is essentially movement of electrons. So electrons are particles that make up atoms, and they move around in an electric circuit. So again, the movement of those electrons carries electrical energy. So we've been talking about different forms of kinetic energy, moving energy, but there's a few other forms of energy that we'll talk about now that are where the energy is not moving, it's stored, and we call that potential energy. It's potential energy because the energy has the potential to be used, has the potential to do work. So these books have potential energy. They've been put up on this shelf, so they've got the potential to do work. If they fall off, they can do work by applying a force to the ground. So the first form of potential energy is gravitational potential energy. So that is energy stored in an object when it is above the ground. So this girl has increased her potential energy, gravitational potential energy, by climbing up the ladder. She's moved higher up off the ground, so she's got higher gravitational energy. So the higher an object is, the more gravitational potential energy it will have. So climbing right to the top of this slide, the girl would have much more potential energy than just climbing to the top of this tiny slide. The next form is elastic potential energy, and that's energy that's stored in a stretched or a squashed spring. So pulling back on some elastic or compressing, pushing down on a spring will store energy, and then when you let go, that energy is suddenly released. Another form of stored energy is chemical energy. So chemical energy is energy that's stored in the chemical bonds of substances. There's quite a few forms of useful chemical energy. There's chemical energy in the food that we eat, and that energy needs to be released for our bodies. There's chemical energy in fuels like petrol that we use for our cars, and chemical energy in batteries. The final form of stored energy we'll talk about is nuclear energy. So that's energy that's stored inside the center, the nucleus of atoms. There's a huge amount of energy being used to hold the particles, the protons and neutrons in the nucleus of an atom together. And that can be released in certain chemical reactions. So a huge amount of energy can be released, and that's used in nuclear power plants, it's used in nuclear explosions, and also occurs inside stars. So that's the end of this first video. Just a reminder of what should be in your notes now in your exercise book: the definitions of energy, work and joules, the conversion chart, and a list of all the different forms of energy that we've talked about with an explanation and an example of each.